In this video, we are going to look at a couple different examples working through how to solve exponential functions. Okay, and so with this, one of the rules that we are going to use is the idea that if, say, b to the x is equal to b to the y, then your exponents x would equal y. So in other words, what this is saying is if your bases are the same, then your exponents have to be equal. And we use that idea when we are trying to solve in order to help. So the idea says that you have to try and make your bases the same. So in this case, I have 3 to the x on the one side, and I want to look at, can I turn 9 into 3 to some power? Well, in this case, the answer is yes, I can turn it into 3 squared. Since my bases are the same, my exponents are the same, so in this case, x equals 2. And we have now solved our problem because we solved for x. Okay, that's really as simple as it gets. So I've just got a couple more examples here of different types so that you can see how to work through them, especially as they get a little more complicated. So let's look at this one over here. So here I have 3 to the x is equal to 1 over 27. Well, the first thing I have to do is I have to use my negative rule, and I'm going to reverse it. So I'm going to change this so that it says 3 to the x is equal to 27 to the negative first power. Because remember, that negative rule says you flip it to make your power positive. Well, here we want to work backwards so that we can use this rule. Okay? So we've gone ahead and done that. So now I want to look at, can I change 27 into 3? Well, in this case, I can. So I still have my 3 to the x. But 27 is the same as 3 to the third, but then we've got this negative 1 out here. So power to a power says you multiply your powers. So here we're going to have 3 to the x is equal to 3 to the negative 3. Therefore, applying our rule, we know that x is equal to negative 3. Alright, let's do another one. Here I have 27 to the 2x minus 1 is equal to 3. So first, I want to make my bases the same, so I can turn 27 into 3 to the third, but then I still have this 2x minus 1 up here, which means this is going to be 3 to the first. And I put this first power here specifically because now we can use the rule. The rule says my exponents have to equal each other. And so it's a good idea to put this 1 here just for the rule. I've seen it happen a lot of times with students that if we forget to put this power of 1, we set this equal to 0, and that's a totally different problem than what we have here. So now we just need to solve. So we're going to distribute the 3, so this becomes 6x minus 3 equals 1. So we get that 6x is equal to 4. So x is equal to 4 over 6. But remember, you always have to reduce, and in this case we can. I can pull a 2 out of both top and bottom, so this becomes 2/3. Alright, let's look at another one. Here I have 5 to the x and the square root of 25. So this is 5 to the x, and the square root of 25 is the same as saying 125 to the 1/2 power. I want to turn 125 into 5, and so I can. My 5 to the x stays, and this becomes 5 to the third, and I'm still to the 1/2 power. Again, here I'm power to a power, which says multiply, so I have that 5 to the x is equal to 5 to the 3/2. Therefore, we end up with x is equal to 3/2. Alright, last one I have for you all is this one. I've got 25 to the 2x, and I have 5 to the x plus 6. 5 is the base, so this is going to become 5 squared to the 2x is equal to 5 to the x plus 6. So this is really 5 to the 4x is equal to 5 to the x plus 6. So we get that 4x is equal to x plus 6. So we have 3x is equal to 6, which tells us that x equals 2. So there is, there you have it. It is a small introductory little mini lesson of different examples where what we're doing is we are solving elementary exponential equations using the rule which states if your bases are the same, then your exponents are the same. So if you have any questions, let me know. Otherwise, I do hope you enjoyed yourself as much as I did, and I will see you next time.